Okay, Year 11 methods. I haven't recorded one of these for a bit, so I thought I'd just catch up with where we're at with this section on polynomials, division of polynomials, etc. I might just start by looking at right, this is another method. If you're struggling with the division of polynomials, this is something that in Perry House last night Manny showed us a method that he'd been showed by Mrs. Long in another class. It's ridiculously quick, and you may want to dismiss it, and you may not even want to watch this section if you're happy with your division of polynomials. But I'm going to do an example. I'm going to use an example that we have already used. It's this one up here, where we're dividing x minus 2 into 2x cubed minus x squared plus 4x minus 3. I'm going to use a different method. I'm going to show you this method that we looked at last night. I'm going to call it the speed method of dividing polynomials. As I said, please, if this confuses you, just dismiss it. Just don't worry about it. But it might be worth watching just to see what you think. So we're doing a division of x minus 2 into 2x cubed minus x squared plus 4x minus 3. Okay, now bear with me, this is a method. I only just learnt this last night myself, so I'll just make sure I get this right. What we do is we drag down initially the coefficient, just the coefficient, the number of the x cubed. So the coefficient of x cubed is 2. I drag that down there. I'm just going to draw a little line in here because I think that's important. Now what I do with the 2 is I multiply it by the minus 2, because I've got a minus 2 there, and I write the result up here. The 2 times minus 2 is minus 4. Now, right, what we've got to remember here is that we're always subtracting. So I'll tell you what we're subtracting. We're now going to take the coefficient of the x squared, which is minus 1, and I'm going to subtract minus 4. So minus 1 minus minus 4, which is minus 1 plus 4, which is 3, and I'm going to write 3 down there. Now 3, I'm going to repeat this process. 3 times minus 2, remember I did that here with 2 times minus 2 to get the minus 4. Now it's, so whatever the number ends up with down here, I multiply by minus 2 and write the result up here. In this case it's minus 6. Now I take this coefficient, the 4. 4 minus minus 6. 4 minus minus 6 is 4 plus 6, that's 10. So I write down 10 there. I take the 10, I multiply by the minus 2, I get minus 20. I then take the minus 3, subtract minus 20, and it's minus 3 plus 20, which is 17. These are all pluses. I should probably put just pluses in front of them just to note that they're all pluses. So that is finished, and I'll show you what this looks like now. So the result of dividing this cubic by this linear is, and we now just put the algebra back in, is 2x squared plus 3x plus 10 plus 17 over x minus 2. 2x squared plus 3x plus 10 plus 17 over x minus 2. Is that the same as we've got up here? No, it's not that one. There it is there. 2x squared plus 3x plus 10 plus 17 over x minus 2. It's the same, and it's really fast. You might want to. I won't do any more on that. You might want to, if you like that, you might want to look at that with some of the other examples that have been done. And if that gets you where you need to be, then go for it and use it. I quite like it. It's quick. Okay, so that's polynomial division. Right, so what I'd like to do now is just have a little recap of the remainder and factor theorem. You should have some notes on these, but just in case you don't, the factor theorem, and this is, I mean, this might be just something you can just view and use as a little revision tool at the end of the week. The factor theorem states that, so I'm not doing it, I'm going to do the remainder theorem first. I'm sorry, remainder theorem. The remainder theorem states that the remainder, thanks for that, the remainder when the polynomial at x, that's what px means, when px is divided by x minus a, is equal to the polynomial's value at a. And we've looked at some examples of that. Now there was, if we're dividing by something like 2x minus 1, or so there's a number and there's a coefficient of the x, then there is just another there is another little element to this. So the remainder when px is divided by x minus a is that. What I might do is that's just part 1. Part 2, if there's an ax, if we're dividing by ax plus b, so divided by ax plus b, that will be equal to the polynomial's value at minus b over a. Now you can see that part 2 actually also works for part 1, as it should, because in part 1 a is actually equal. I reckon I'm confusing you here by using a there and then a there. That's poor. I reckon I'll change that a there just so that we're not getting confused. I'll just make that a k. Okay, so if we just look at the part 2 version, in part 1 a is equal to 1, so you can see there that this just becomes minus b over 1. The other difference with part 2 to part 1 is that this is a plus sign, so we have a minus in here. But because we're most often dividing by this type of linear in part 1, then it's worth just remembering that one, because 9 out of 10 we're just doing that. If we divide by x minus 2, we sub in 2. If we divide by x plus 2, we sub minus 2, the opposite sign, into the polynomial. Okay, so we find the remainder that way, and we've done plenty of examples on that. Now if the remainder happens to be 0, then we have a factor. So that leads us to the factor theorem, and that says that if the remainder upon division is 0, then the divisor is a factor of px. So if the remainder goes to 0, then the divisor is a factor, and we know that from way back. If we take 24 and divide it by 4, we get 6. No remainder. Remainder 0. So 4 is a factor of 24. Whereas if we take 26 and divide it by 4, we get 6. Remainder 2. So that's not 0. So 4 is not a factor. So that's really pretty straightforward stuff. But we're just applying it now to what we know here in polynomials. Okay, so there's the remainder and factor theorem, and they're there for your notes. Just one other thing I'd like to do is perhaps just I've set you 7C to finish, and 7D. 7D, just questions 1, what have I said? 7D, this will be in the prep portal, but I'd certainly get you started on it now. 7D, question 1, AD. Okay, so just to get you started on that, so exercise 7D. Question 1, I won't do A because that's yours, I'll do B. Without dividing, it says, show that the first polynomial is exactly divisible by the second polynomial. So x cubed plus 3x squared, this is just straight out of the book. We need to show that x minus 1 is exactly, so that polynomial, that cubic, is exactly divisible by x minus 1. One other way of saying that is x minus 1 is a factor. So we do that just by substituting 1 in to this polynomial. So 1 cubed plus 3 times 1 squared minus 1 minus 3 equals 1 plus 3 minus 1 minus 3, which equals 0. So therefore a factor. So that's all we're doing in question 1. In question 2, again, I won't do a question that you're doing. So you're doing A and C, I'll do B. In 2, you'll find the value of m if the first polynomial is exactly divisible by the second. So in part B, I'm going to take 2x cubed minus 3x squared minus m plus 1x minus 30. And I need to, x minus 5 is exactly divisible. That means the remainder, when I sub 5 in, will be 0. So 2 times 5 cubed minus 3 times 5 squared minus x is 5, so that's 5m plus 1 minus 30. That all has to equal 0. This is 5 cubes 125, so that's 250. 5 squared is 25, so that's 75. Minus 5m minus 5 minus 30 equals 0. So from all this we get 5m equals 250 minus 75, 175, 170, 140, I think I got out of that. 175, 170, 140. So minus 140, so m, if I've got my arithmetic right, will be equal to minus 28. So you can do the same for question 2. And then question 3, I think I'm just getting you to do A and B. Quickly, yep, so I'll do question C as just a demo, just in case you find this useful. Question 3C, you are now just factorising. So it just asks you to factorise, just like the example we did in class on Friday, 6x cubed minus 13x squared plus 13x minus 6, and we're factorising it, so we need to find initially a factor that works for it. Remember, we're going to check plus and minus 1, 2 and 3. Firstly I'll check my battery's running out, I better hurry up. I'm going to check x equals 1, which is 6 minus 13 plus 13 minus 6, so that works, hopefully. So that means x minus 1 is a factor. And therefore I'm now going to do a division of x minus 1 into 6x cubed minus 13x squared plus 13x minus 6. Because I'm running out of time, I'm going to use, so this will be 6x squared here, so I get 6x cubed minus 6x squared, doing a subtraction, minus, so I end up with minus 7x squared is 13x, so minus 7x here, minus 7x squared plus 7x, so I end up with 6x minus 6, so it's plus 6, 6x minus 6, I'm now out. So my factors are, so I now need to factorise 6x squared minus 7x plus 6, that's equal to, multiplies to 6, adds to, so it's minus 6 minus 1, 6x minus 6, 6x minus 1, 6 is just my quick technique, so that's x minus 1, 6x minus 1. So I've now factorised right the way down to x minus 1, x minus 1, 6x minus 1. So that's the task in question 2. I've asked you, sorry, in question 3. I've asked you to do A and B. Excellent. Hope you've had a good weekend. See you on Monday. Hope this has been of some help to you.